Every year, tens of thousands of people die on our nation's roadways. But thanks to emerging transportation technologies like sensing and communication devices, researchers are promising a vast improvement in safety.
I think we are in an exciting time in the transportation landscape. The one thing that I know the entire profession is trying to handle is how do we reduce the fatality rate that exists in our country. With the new technologies that are coming into play, there is a very real possibility of getting that to zero. And the faster we can get that to zero, I think all of us in the transportation profession would be happy, because it is humbling that we haven't been able to get that down. It's been so sticky over the years. So that is the real reason we started on this project.
The project, Communications and Radar-Supported Transportation Operations and Planning, or CARSTOP, does what most other research does not. It combines both sensing technologies like radar and cameras with vehicle-to-vehicle, or V2V, communication technologies in order to improve safety.
We believe we have to bring communications and sensing together, and we are trying to do it in as effective a way as possible, as economical a way as possible, and we want to show that this works.
In part, the research team developed a new joint communication radar paradigm for automotive applications using next-generation millimeter wave communication. Showed through concepts and simulations how V2V communications and radar systems can substantially reduce crashes. Developed a joint radar and communication hardware prototype demonstrating the feasibility of combining these two technologies. And determined that substantial safety improvements are only possible by combining both sensing and communication systems.
3 applications of AV, autonomous vehicle technology, and 3 specific demonstrations of these applications that we've developed here at UT. The first one being a construction site, a simulated construction site, where you have a tower with a bunch of sensors on it, and it detects where people are, where vehicles are, where barricades are, and it can tell you when there's something that's dangerously close to each other. The second one was a pedestrian detection demo where the vehicle is equipped with a radar and a LiDAR system with camera, and it detects where people are in front of it, how far they are, and if it's actually a person or anything else. And thirdly, there was the highway merge demo, which in a lot of cases when we're dealing with construction zones, there is no formal exit from the construction zone to the highway. So it's dangerous because there's no red light, there's no way to stop or to slow down oncoming traffic when you're trying to merge onto the highway. And that's a place where a lot of accidents happen. What we implemented was a communication system where the person who's waiting to try to merge on the highway gets a signal saying it's safe to go, or calm down, there are other people coming on the road. These are the first steps towards what could be something much greater.
In addition to safety improvements, new technologies also have the ability to help with traffic management.
We can say, okay, this crash is exactly at this point on the road. It's on the northbound lanes rather than the southbound lanes. It's in lane 1 versus lane 3. If we can get accurate information to that degree, helps us greatly help others, helps us clear incidents quicker, helps us get help services to incidents quicker. The more accurate the data is, the more we can use it to help others.
The benefits of saving a life is huge, not only to society, but to TxDOT as a whole. But also, safety is a huge consideration, but it can also lead to improvement in efficiency. If you have fewer crashes, you're going to have lesser traffic congestion on the roadways. So improvements in safety will lead to improvements in traffic mobility.
For more information and to find the publications for this project, please visit the TxDOT Research Library at the link shown below.